Okay, so we're starting to get comfortable using all these different classes to create objects. Now let's make an object that's a little more complex. So everything we've done to this point is taking an individual motor or a sensor or a controller, giving it a name, and then just directly programming that object, correct? And then there is one video and also how you group motors together and then to program those as a combined object. Well, what if you took your whole drive base and then turned that into an object of its own, and you could call that object anything you want? So you could literally just call it robot and then tell your robot to turn and move and navigate the field, right? So that would make the programming for that very simple. This is also very useful for something like an autonomous program where you don't need to loop through a whole sequence of code because you're driving it, but you just need to go step by step by step and wait for each step to be executed before it goes on to the next part of your code. So to do this, there's a class called Drivetrain, right, which is right here. And this is everything you can make the drivetrain do. So let's see if I can pick up on one real quick. Turn for, that's useful. There's also a drive for. So there's a couple different, like turn for and drive for, probably the two I'm going to show you how to use, right? And then to define the object itself at the very, very top, this explains how you define the object. So this looks confusing, but if you learn to read this and break it down, it's not that bad. All the parameters are defined. So if you're not sure what something means, you could just read it below. And it straight up tells you, okay, you're going to have drivetrain. And then to define an object inside parentheses, you're going to do your left motor or motor group, then your right motor or motor group, and then you're going to do your wheel travel. That is how far is your wheel going to travel in one rotation, right? So essentially, you would have to calculate the circumference of the wheel because that is how far it's going to go in a straight line with one rotation. So that's using like your 2 pi r. Right? And then you're going to have the width of your robot from wheel to wheel. And then you're going to have the length of your robot from axle to axle. And then you're going to specify what units you measured in, and then as well as any external gear ratios. So external gear ratios, I'll give you an example. One of my team kids just built a 6-motor drive using green motors, and then they geared it to have a 5-to-3 gear ratio. So meaning they went from a 60 to a 36 tooth gear for their drive base. So instead of moving at 200 RPMs, I believe it's at like 330 or something like that, right? Just to kind of give you an idea. Um, so, so how can we use this information? Well, let's look at what this looks like in the code. So here I've written a simple program. So let's just comment this out for now. Okay, so I have the drivetrain class, and I'm creating a robot or an object called robot. Okay, just to keep things simple. So I'm going to tell my robot to do stuff. So it'll be robot dot, and that is equal to, and here are all the parameters for that class, right? So first I had to put my left drive motor, then my right drive motor, my wheel travel. Remember that was that 2 pi r, or 2 times the radius is just the diameter. So the diameter of the wheels I have on this clawbot are only 2.75 inches, and I'm multiplying that by pi. So I can do the math right inside. I don't actually have to calculate anything out on a calculator or by hand. The width of the clawbot is 11 inches from wheel to wheel, and then the length of the clawbot from axle to axle is 9.5 inches. So I measured those in inches, and I have no external gear ratio, so it's just a 1-to-1. So I can put 1 there in place of that. So what does this allow me to do, right? So I wrote one line of code so far. So I have robot.drive4, and I'm telling it to drive for 24 inches, right? So if we look at the field real quick, that essentially should make this go one full tile, right, to the right. Um, so let's come back here. Well, not only do I want to do that, I am also going to tell it to turn. So I'm going to do robot dot, let's do, whoops, lowercase, turn 4. Um, and then I'm going to do, let's make it just turn around a complete 180 comma and then degrees. Okay. So the only thing you have to be careful about, and then we'll make it drive back. So I'll just repeat this same step. This is not always exact. So depending on your robot and depending on how efficient that system is, it might not turn exactly 180 degrees. You might have to make some adjustments to your drivetrain, all your parameters to get it to be more accurate. So you can play around with those numbers. You could also just adjust the degrees directly, right? So you could kind of power your way through it and make it work exactly as you want. So let's go ahead and download this. Okay. Um, and what we should see when I play this, oh, we got an error. Why do we have an error? Let's try downloading that again. Right. What we should see, there it goes. When we play this is that it will drive forward, turn completely around, and then drive back. So there it goes. That's about 2 feet right there. It drives all the way around, and that is not 180 degrees, right? So that's what I was saying, how you would have to mess around with this to make sure it's more accurate, okay? Um, so that's kind of the basics. So what does this look like with motor groups instead of individual motors? It's not much different. So I'm going to actually go, let's go File, Open Recent, and I'll open up my motor group file where I was using this robot, right? Um, so this has a larger diameter wheel. So essentially, let's look at this. I'll bring up my drivetrain. Let's do, I'll make this a little bit bigger to read, control down. There we go. And then I'll get rid of this comment, okay? So I've already gone through this. So you would put your left motor. So instead of left motors right here, I called my left motor group left drive. So the code itself is no different than what we just did, right? So I'm just going to type right in here, I'm going to just type drive, right? So there's L drive, and then I'll change this one right here to R drive. And I can actually go through and do all this, which that should be a capital D. That's why it's not reading it. My travel, in this case, this is a 4-inch wheel right here. So I'm going to do 4 times, which is just an asterisk, and then I'll do pi, which is 3.14. The width of the robot, you can just use a tape measure. So the width from wheel to wheel on this robot is about 10, a little over 10 inches. So you can do decimal numbers if you have to. So I could put 10.25. I mean, just to walk you through this, the length going from axle to axle on this robot is about 11 inches, right? So I'll put 11. And my unit of measurement, this is where I'm just going to write inches, right? And then my external gear ratio, this one also has no external gear ratio. So it uses sprocket and chain, but that's only to divert power down from the motor. There's actually no, they're the same size gear. So that's a 1-to-1 ratio. So I could just put 1 there. And now I just set up my drivetrain function for a robot that has motor groups, right? So that's as simple as that. Now you could actually figure out and play around with it, try to get it more accurate. And from there, you could actually navigate around the field and start writing an autonomous code. All right, if you have any questions, let me know. I'm always happy to help. All right, guys.